A parabola is just one type of a group of graphs called conic sections. All of these are known as conic sections because they can be formed by a plane, like this orange plane, cross-cutting a cone. This here is a cone in 3 dimensions. The parabola is this cross-cut. A circle is another conic section. An ellipse or an oval is a conic section that actually includes the circle. The circle is a type of an ellipse. And a hyperbola is the last type of conic section. Now, all of these conic sections are formed by squares. A parabola is y equals x squared. A circle is a sum of squares. An ellipse happens when you still got a sum of squares, but one of those is stretched out. And lastly, a hyperbola is a difference of squares. But all of them are about the squaring relationship. Well, why are these squared graphs important to thinking about rockets? Well, the answer is that law. It was first formulated by Newton, Isaac Newton. Oops, no 2 S's. And you'll be learning more about it when you get into the science of this unit. And it basically has to do with how gravity or light or other forces emanate from a point into 3 dimensions. But the inverse square law says that gravitational impact will have a result that decreases in inverse proportion to the square of the distance. Meaning, as you get further and further away from another object, like the sun or Earth, gravity has less and less a result. So all gravitational motion happens based on this inverse square law, which means all orbits or trajectories of motion in space happens on an inverse square law. So Earth's motion around the sun is elliptical. That's a conic section. When we send a rocket into orbit, it will go into an elliptical orbit. When we send a rocket out of our orbit, like we want it to go to Mars, like they did in The Martian, then it has to be on a hyperbolic path to achieve escape velocity, to actually leave the Earth's orbit. And you can have a parabolic path in space, but it's very rare. It's exactly the amount needed to leave Earth's orbit. But what's much more common is that you have parabolic trajectories on Earth. Let's take a look at what we mean. All falling objects happen parabolically. This one's really easy to see. If I shot a cannon, the path of the cannonball would form this parabola. So it's easy to see why those of you who are going to be shooting your rockets at an angle are going to need to understand parabolas, because the path of your rocket will so clearly be modeled by a parabola. But everyone who's doing the egg challenge also needs to understand parabolas. And let's look at that as well. Here's a quick movie where I drop a ball. Balls drop pretty fast, so it only takes about a second. One last time, there it is. It's hard to see here, but when I slowed this video down really slowly, so at each moment, let's plot a point for this first moment. Here it is at 0 time, and it's up here at 1 meter high for that first moment. And then let's move forward a little bit in this movie, and there it's dropped a little. So the next 1/10 of a second later, it's down here. And as I move forward in time, the next 1/10 of a second, there it is down here. Notice I'm plotting the heights. And this down here is time. So this is the height axis. And I'm looking at the height based on a meter stick that I dropped next to. So these heights are coming. This was the first height, then the next height, then the next height. And let's keep moving forward in time. There's the ball down there. The next time. And forward again, and there it's dropped a fair amount. Keep moving forward in time. And again, here's the ball down to there. And now the ball's going pretty fast. It was going really slow right when I dropped it, but now the ball's going really fast. And for the last moment, it drops quite a bit, all the way down to the bottom there. So that curve of the ball's path over time is also modeled by a parabola. So falling objects are modeled by a parabola. And when you throw something or shoot something straight up into the air, it's also modeled by a parabola. Let's take one last look. So again, I'm going to be thinking about height over time, since most of you are doing that egg challenge. We're going to shoot something straight into the air. When you do that, your rocket will be leaping up in the air, going really fast right at the beginning. See how it covers a whole ton of height right at the beginning? But then it'll slow down and slow down and slow down until at some point it stops. And for a moment it'll be stopped right in midair before it starts coming back down to Earth. That's the path of an object shot into the air over time. This models its height at various times. And again, that path is parabolic. So no matter whether you're shooting your rocket forward in space or shooting your rocket straight up and down, its path will be parabolic, which is why you need to understand parabolas and the equations that make them, quadratics, for this rocket project.